Hey everybody, Mr. Piercy here, and what we're going to be discussing in this lesson is what generally in geometry is known as a conditional statement. A conditional statement is something that comes in the form of an if-then format. So before we get too much into what a conditional statement is, let's just take a look at the hypothetical situation that we have starting out with our handout with our notes here. The instructions are telling you, okay, a company is printing bumper stickers, and the original bumper sticker is the one that's on the left. Now in the video it may not be the easiest thing to read, but hopefully you can see it in your handout. But the bumper sticker on the left says, if you can read this, then you are too close. For the purpose of this exercise, we're going to say that the statement is true. Now, the bumper stickers on the right are bumper stickers that were misprinted. And what we want to be able to do is, okay, well, let's take these bumper stickers. When we compare them to the original one, are they true or not? No. So bumper sticker A, if you're having a hard time reading it in the video, again, you should be able to see it in your notes, but it says, if you are too close, then you can read this. Bumper sticker B says, if you cannot read this, then you are not too close. And bumper sticker C says, if you are not too close, then you cannot read this. So what I want you guys to do is pause the video when you're ready and determine, are bumper stickers A, B, and C true or false? And if they're false, provide a reason why they're false. So when you're ready, pause the video, and when you're done, come back. All right. So again, I'm going to just assume that you're doing what I told you to do. The bumper stickers here. Bumper sticker A. If you are too close, then you can read this. Well, this, guys, this is going to be a false statement. Now, why is it false? Why am I saying it's false? Well, the counterexample that I am providing for why I'm saying it's false is I'm saying if I'm too close, I may not be able to see it. Why is my cursor off the word the? There we go. If I'm too close, I may not be able to see it because the front of my car is in the way. And just imagine if you've ever sat in the front seat of a car, you're sitting in a red light, sometimes you pull up close enough to the person in front of you that you can't see their bumper anymore because your hood is blocking your view. Now, if I can not see the bumper sticker, then the statement must be false, because if it says if you are too close, then you can read this. Well, if I'm too close, I may not be able to read it. Now, moving on, bumper sticker B. Here, that statement is also false. Now, the counterexample that I'm providing may not be a counterexample that you provided, and some of you may even try to argue with my counterexample. I'm saying it's false because I may not be able to read it because I have poor eyesight. I may not be able to read it because it's in a language that I can't understand. Okay, but that's why I'm going to say it's false. And so the last one says, if you are not too close and you cannot read this, that bumper sticker is true. The original bumper is true, so this one is also. Now, well, before we move on, I want you guys to understand the idea of when a statement is true and when a statement is not true. In math, particularly in geometry, if a statement is true, it must be true 100% of the time. If a statement is false, it only has to be false once. I could have 100 reasons why it's false or why a statement could be true, but if I can come up with one valid reason why it is not true, then the entire statement is false. So while you may not necessarily have considered the counterexamples that I am choosing for why I'm saying these statements are false, they are valid reasons and therefore make the bumper sticker a false statement. Now, here, what I want you guys to do is to try and come up with a couple of conditional statements of your own. I want you to write them in an if-then form, the way the bumper stickers were. And I want you to make one of them true and one of them false. And now I know you guys may or may not be able to share with somebody that's in the actual same class with you, but I still think you could share it with somebody. Now here, the green, this is a little hard to see, the text, but the conditional statement that I have here, and I'll write it out here on the side, says, if you're eating fresh sandwiches, if you're eating fresh sandwiches, then you're eating at Subway. That is very clearly a false statement because, well, I could eat a fresh sandwich at home. I could eat a fresh sandwich at Jimmy John's. I could eat a fresh sandwich at Quiznos. So there's lots of places I could eat a fresh sandwich, not at Subway. So those are counterexamples. So let me give you one that's true. If 3 points are not on the same line, then they form a plane. That is true. That is Euclid's second postulate. And remember, a postulate is a statement I can accept to be true. So there's an example of a true statement and a false statement. I want you guys to come up with your own. So pause the video, figure out what you want to write as your true and false statements, and compare them either in with the individuals that are sitting with you in the classroom where you're located, or in the comment section, and see if you can determine why they're true or why they're not true. So moving on, here's a definition of what a conditional statement is. First of all, the conditional statement, here's the definition. It has to come in an if-then format. Now, it has two parts to it. The part that comes after the word if is called the hypothesis. And the part that follows the word then is called the conclusion. Moving on to the symbolic representation, because you know math loves its symbols, and geometry particularly so, says, I'm going to write this out just in case it's a little difficult to see in the video. This says P with the arrow here, and then it says Q. All right? And we read that statement as if P, then Q, or P implies Q. And here is a symbolic or a visual representation of it. The diagram that we have here is a Venn diagram where, and I'm not sure we can see that green there because it's kind of a dark color on a dark color. Let me just go black on this one. I think we can see here. So here, that P represents the hypothesis, and of course the Q represents the conclusion. Now the Venn diagram, the way that we would look at this is we'd say that the hypothesis is actually a subset of the conclusion, or we could say that the hypothesis is an element of the conclusion. Essentially what we're saying is that the hypothesis is kind of is going to be more specific, whereas the conclusion is going to give you a little bit more of a broadness to it. So there is the definition and the ways that we can represent a conditional statement. Now let's take a look at our at our conditional statements here. So I'm giving you two conditional statements, and I want us to be able to identify the hypothesis and the conclusion. So here, let's identify the hypothesis, and I'm going to do this in green. The statement says, if an animal is a robin, then the animal is a bird. Okay. Well, I don't know if we can see that. I don't want to highlight over it and you not be able to see it in the video anymore. Let's go back to pen and green. So I will box the hypothesis. So if an animal is a robin, that is the hypothesis. And if you want to, you can write it out, and we say an animal is a robin. So let's pick a different color here for our conclusion. Now the conclusion, again, comes after the word then. So the animal is a bird is the conclusion. Now, before I do the next one, I really would like you to pause the video and try to identify the hypothesis and conclusion of the second statement if you haven't already done so. So go ahead and pause the video now, identify the hypothesis and conclusion, come back when you're ready. Okay, so the hypothesis and conclusion follow the same order. The hypothesis is going to be after the if portion of the statement, and the conclusion comes second. So here we're going to say an angle measures 130 is the hypothesis, and here the angle is obtuse is the conclusion. Now what I'd like you to do is take a second and think, how could I rewrite those statements so that they're false? So rewrite the two statements and make them not true anymore, because right now the two statements that we have, those are true. Rewrite them so that they're false. When you're done, come back. Okay. Now, in class, when we talked about this with students here at MacArthur, there were a variety of ways that students tried to make these things false. So the way that I wrote them to be false and the way that you wrote them to be false may not be the same, and that's okay. But let me show you how I wrote them to be false. I took the two statements that we had, and all I did is I reversed the order of the hypothesis and conclusion. So I said if an animal is a bird, then it's a robin. Well, that's clearly false because there's lots of animals that are birds, and they're not all robins. And the other one, same thing. I just reversed the order of the hypothesis and conclusion, and I said if an angle is obtuse, then it measures 130 degrees. Well, it could be 91 degrees, and that would be obtuse, and that's certainly not 130. So there's definitely a falseness to that statement. So that's just how I did it, and there's a reason why, and you'll see here soon as you follow through in your notes. Now, the last thing that I want to do here on this idea of what a conditional statement is, here we want to identify what is a hypothesis and a conclusion from a statement that's not written in a conditional form. So here we have a statement that says vertical angles share a vertex. Now, it's not written in a conditional form, and you see on the right-hand side, it's kind of helping you identify what the hypothesis and conclusion is using the Venn diagram. So the hypothesis is going to be talking about something with vertical angles. So, oops, didn't mean to do that. Let's go back to my pen. So here, the hypothesis, I'm going to say P, and I'm going to say angles are vertical. Now it doesn't have, now obviously the word are is not there, and I changed the order of angles and vertical, and that's okay. All I'm really doing is when I'm thinking about this is I want to think, okay, so if I wrote this as in an if-then form, how would the sentence read so that it still makes sense? So I'm going to go ahead and change it up a little bit and say angles are vertical. Now for my conclusion, looking at the Venn diagram, says they share a vertex. So I think that's okay. I think that's just by itself we can use that. We can say they share a vertex. Now, the whole reason why I'm asking you to actually think about what would the hypothesis and conclusion be of a statement that when it's not written in a conditional form is so that way, well, if you do have to write a statement in a conditional format, how would you do it? You have to be able to identify what is the hypothesis and conclusion. Now here you see the word share. You can think of maybe where the verb is. That's where the change between the hypothesis and conclusion is. But they don't always follow that format. But now that we've identified a hypothesis and conclusion, I can say if angles are vertical, then they share a vertex. Here's my happy conditional statement. So what I'd like you to do is for the second statement that we have here where it says dolphins are mammals, I'd like you to also write that as a conditional statement. Now, I'm clearly not asking you to identify the hypothesis and conclusion. The only reason I did in the first one is just to make you think, what do I have to identify in the statement in order to actually put it in an if-then form? So pause the video and write your conditional statement, and when you're done, come back. Now, my conditional statement looks like this. If an animal is a dolphin, then it is a mammal. So clearly I'm adding here the words an animal. Those two words are definitely not in the original sentence, but adding them really does help the sentence actually make sense. And you don't want to say if a dolphin or if dolphin. We need some kind of structure to our sentence. So if an animal is a dolphin, then it's a mammal. So moving on, this is where we're going to pause for today. For this is the last thing we're going to do in this portion of the lesson. Taking these statements, I want you to identify, is it a true statement or if it is a false statement? Kind of like what we did with the bumper stickers. Just kind of wrap things up a little bit, going back to where we started. And when you're done, let me back up a second. Just pause the video, identify whether they're true or false, and if they're false, again, give me an explanation why. Give me a counterexample. So go ahead and pause the video, answer these three questions, true, false, and when you're ready, come back. All right. So here, looking at the first one, if a woman is Hungarian, then she's European. Well, that's actually true. Hungary is a country in Europe, so if a woman is Hungarian, then she will be European also. If a number is divisible by 3, it's odd. That is very false. Let's say 6 divided by 3. Well, 6 is divisible by 3, and 6 isn't odd. If a month has 28 days, then it is February. That is also very false. Every month has 28 days. So here's where we're going to pause for today. I know your notes have more information in them, and we'll come back to that in our next lesson. But for now, if you have any questions over what you've seen so far, again, just like always, send me an email, leave me a comment in the Google Classroom, and I'll be happy to get back with you with whatever questions you may have. But in the meantime, guys, thanks for watching. Take care of each other, and we'll see you soon.